Now we're going to move on to our second case. Our second case is about distance between 2 points. So how do we do the distance between 2 points? Well, if I give you the graph here and tell you you have a point A and you have a point B, and let me label them, so A and B, and you want to find the distance between them, which is this distance. Well, what you can do is you want to have your origin start here and your endpoint start here to get the vector AB. And in order to do that, what you're doing here is you're basically adding, you're going from A to O, and then you're going from O to B, which is what we basically know here as it is AO plus OB. And what you want, if you want to find it, in order to get the modulus here, you just need to find modulus of AB after finding AB itself. But we can do it in a shorter version, because there's this rule which applies here, that if you want to get the distance between 2 points, and you know that A is x1, y1, and you know that B is x2, y2, then the distance between them is going to be the square root between the difference. So you're going to do x1 minus x2 squared plus y1 minus y2 squared, and you're going to find the square root of that. Why is that? Simply speaking, because if you want to find the summation here, what you're doing, if you want to do the summation here, first you're subtracting, because you have one of the position vectors as negative, because this will turn into negative OA. And the second thing you're going to have is that you're going to find the square root to find the modulus of this and of that, and then you're going to add subtract. So this equation actually just summarizes what we do in a long version. Similarly speaking, if you're going to do this in 3D, you're going to just go on to add your z1 minus your z2. And of course here, yes, I said in y1 and y2, it's not wrong, but it's always preferably to think of them in the ijk plane, but I didn't use them in order so you wouldn't confuse them. So z1 minus z2 all squared, and this would give you the distance between any 2 points. From then on, we can move on to our third case, which is the scalar, or also known as the dot product. What is the scalar or the dot product? It's basically the product of any two vectors. So if you have vector A multiplied by vector B, you can find the answer as the magnitude of A multiplied by the magnitude of B multiplied by cosine theta. If this does not seem familiar enough for you, then that's weird, because cosine rule looks very familiar. So here, if I want to graphically show you this, if you have a vector A or vector A, and here you want to find, and you have vector B, and this is going to be the angle theta between them, what you're going to do is that you're going to find, if you want to find the product of those two, you simply multiply the magnitude of this one and the magnitude of that one times the cosine of the angle in between them in order to get them. Now, regarding the dot rule, the dot scalar rule, I want you to remember certain important things here. If you remember that our ijk are actually the graph where all of them are perpendicular to each other, we want to know that if you multiply any unit vector I by itself, or any unit vector j by itself, or k by itself, you're going to get 1, because the magnitude of a unit vector is 1. So if you multiply I by I, that's 1 by 1, 2, which gives you 1. And since they're perpendicular, they're 90 degree, and since they're, if you're talking about I and times I and j, then they're like I is parallel to I, or it's the same exact thing. So the angle between them is actually 0. So cosine 0 is 1. So 1 times 1 times 1 is going to give you 1. And on the other hand, if you do I times j, or I times k, or j times I, or j times k, or k times I, or k times j, this is going to be, yes, unit vectors 1 times 1, but cosine 90 is 0, so this will eventually lead to 0. And these are just rules that you remember because they make your life easier. You can do a whole calculations, and in the end you find that there's a JKO is 0, so your whole thing will go to 0. Now let me give you an example on this part, on the scalar or the dot product rule. Here, first of all, it's multiple parts. It asks you to find ij, which we did here as 0, so I'm not going to go through that again. And then kk, again we went through that, so it's 1. But the c part is what interests me. It tells you that 4j into k plus 3i, 3i. What you're going to do here is that, what you're going to do here is that you're going to just apply the rule. You know that the magnitude of 4j is going to be 4 because it basically goes up 4 units, so there's only a j component. So your magnitude of 4j times your magnitude of k times cosine theta, plus here the magnitude of 3i into magnitude of 3i times cosine alpha. And because you know these are parallel, you know this is going to be 1, and because these are perpendicular, you know this is going to be 0. So instead of actually doing this calculation, you just know that it's going to be multiplied by 0, so you're going to say, okay, so let's just start with the 0. Here you know this is 1, this is 3 times 3, so it's 9, so yes, this will have a value 9, and the answer is going to be 9. And this is how knowing this scalar dot product using the unit vectors is going to be really helpful and makes your life easier. And the questions are simple and straightforward to use when you actually understand the whole idea of them being perpendicular or parallel to each other. And that would be it for the third property.